You cannot separate climate from biology, so you cannot even separate climate tech from biotech. They are the same thing. The thing I always say is the Venn diagram of climate and biology is a circle.
Hi, everyone. Welcome to the Grow Everything podcast. This is Karl. Erum is on the other side of the planet, so I'm recording this today alone, not from my usual studio. I'm actually in upstate New York recording this introduction. As we head into the end of the year, we thought we would replay one of the most popular episodes, which is our interview with Kristin Ellis of Lower Carbon Capital. I've been lucky enough to know Kristin for many years. I met her when she first joined Opentrons, which is a Brooklyn-based laboratory automation company that has been wildly successful. Kristin and I became friends while she was at Opentrons, and then when she left to join Lower Carbon Capital, we've stayed in touch. Lower Carbon Capital is an investment firm that focuses on climate tech, that is, climate-related technologies. It's a pretty big fund. I believe it's going to be a very successful fund. And Kristin is one of my favorite people. She is incredibly intelligent, has a definite point of view, and Erum and I really love this episode. You may have heard us say the Venn diagram between biotechnology and climate technology is a circle. Well, that quote actually comes from Kristin, and if we ever say that without acknowledging her, that's a mistake on our part because she is the one who came up with that quote. And the reason being is climate tech looks to biotech, and biotech can be a very pro-climate technology. We're not talking about biopharma, that is biotechnology applied to pharmaceuticals, but biotechnology applied to creating new materials, new foods, even absorbing carbon from the atmosphere. If you've listened to the Grow Everything podcast for more than a few episodes, you may have heard the episode with Lauren Burnett of Prometheus Materials. Prometheus is making a type of cement using the same microorganisms that create coral reefs. That's an example of climate tech that is being driven by biotech or biotech in the service of climate technology. So let me leave it here, short intro. Enjoy the episode with Kristin Ellis, and we look forward to being back with you next week with an all-new episode of the Grow Everything podcast. Thank you.
Hey, Kristin, welcome to the Grow Everything podcast.
Hey, y'all. Excited to be here. Thanks for having me.
We're thrilled to have you.
It's about time. You're a good friend of ours. We love seeing you at events and all other times that we've hung out. Man, we've known each other for a really long time. Has it been like 10 years?
Probably, yeah.
At least.
We made it from the beginning of Opentrons until you left to go to Lower Carbon. So that's a chunk of time.
Big chunk. You started your career as a cancer researcher, and then you were an early employee at Opentrons. So how did you make that transition?
It's really interesting, right? So when I started at MD Anderson, I was weighing my options. So I came out of college with a shiny new biochemistry degree from the University of Alabama at Birmingham, and I thought I wanted to go to grad school. And I didn't exactly know what I wanted to focus on or what I wanted to be when I grow up. And that's going to be a theme. Anytime you ask me what I want to be when I grow up, I think my answer is going to be, I don't know, but I have some idea of a direction. And my idea of the direction going to MD Anderson was, I think I'm pretty passionate about cancer research. Cancer is fascinating. It's a huge problem. It's a very multidisciplinary, interdisciplinary problem. There are a lot of different modalities of the disease. There's just so much to explore. There's so much to learn and uncover and work on. And so I took a gap year and started running bench to bedside clinical trials at MD Anderson. And in that role, I was actually exactly the person Opentrons was trying to help. Someone doing complicated, repetitive, and expensive biology lab experiments involving tons of pipetting.
Hi, everyone. Kristin mentioned pipettes and liquid handling. We defined pipettes before, but as a refresher, a pipette is like a mini turkey baster designed to move very small quantities of liquid, for example, a drop of water, from one place to another. Pipettes are designed to be very precise.
for laboratory work. In fact, pipetting is a human skill, but because it's a human skill, it's prone to error. As Kristin mentioned, there are liquid handling solutions that automate the moving around of liquid in the lab, but they're very expensive. OpenTrons built the first open source, very affordable liquid handling solution. Look it up on the internet. It's pretty cool.
And several different pieces to that journey, but I ended up meeting actually one of the founders of OpenTrons, Will Canine, on Twitter, and he was talking about this robot he was making. And I got really excited about that robot because I was like, oh, I really need one of those robots. And that conversation turned into an interview, which turned into a job. And I ultimately ended up joining OpenTrons as one of the earliest employees and the first bench scientist, the first biologist at the company. And I stayed well past employee 100. And now what's really exciting is most of the biotech companies I invest in at Lowercarbon actually have OpenTrons robots in their labs.
So can you just define what is OpenTrons and why did you feel that there was a need for automation in the biotech industry?
Yeah, well, OpenTrons is a tool. It's a tool that makes bench scientists' life easier. The tagline for OpenTrons is robots for biologists. You could expand that, right? It's not just biologists that use OpenTrons. There are plenty of chemists and other scientists that use OpenTrons as well. But core customer, core collaborator for OpenTrons is the bench biologist. And this also ties into cancer research nicely, right? There's that Nature paper that came out that said more than half of biological studies are irreproducible. That was actually talking about specifically cancer research. And one of the reasons, there are myriad reasons for irreproducibility in life sciences, but one of those reasons is exactly that sort of repetitive tasking at the bench and then lack of coordination between sample labeling, you're writing numbers on little tubes, you're pipetting by hand. And often there's like a grad student or a postdoc in your lab with magic hands that has the exact perfect pipetting technique and no one else can replicate it. And so there are a lot of things in biology, including pipetting, including these liquid handling that experiments can benefit from and scientists can benefit from. And so one of the big reasons or one of the big things that we were trying to unlock with OpenTrons was bringing that automation, which by the way already existed at the top of the market. We've had $1 million or $250,000, $150,000 lab automation machines on the market for decades at this point. But that equipment was inaccessible to the average bench scientist because the average bench scientist does not have $100,000 to spend on a robot. Instead of doing that, we get undergrads, we get grad students to do that repetitive labor. And it affects the quality of the science, not because those aren't brilliant researchers, but because humans are better suited to do higher order tasks. We're better suited to digest the research papers, come up with the experimental designs and plans. We're not that well suited to look at a teeny tiny 96 well plate and put teeny tiny microliters of liquid into every well on that plate. Often you're adding small amounts of clear liquid into other clear liquid. And so you can't even visually see if you're not paying very close attention, whether you've lost track or not. It's a whole boondoggle. You end up wasting a lot of time, a lot of money. But we noticed an opportunity. What OpenTrons is fundamentally as a technology is a supply chain innovation. So consumer 3D printer technology had come way down the price curve in the previous, I want to say 5 to 10 years before OpenTrons was founded. Add to that a burgeoning open source revolution where you had open source motor control boards, smoothie board, open source electronics like Arduino and Raspberry Pi, which could provide the brain of such a robot, and really inexpensive sort of 80/20 aluminum railing gantry systems that were built specifically for a consumer market. So they had to be extremely cheap. They also needed to be somewhat accurate, right, in the XYZ frame. What do you really need to do pipetting? You have a flat plate in a plane, you have an X, you have a Y, and you have a Z going down into the well. And then what do you need to add to that? You need to add a thumb, right? And so the first iteration of the robot was a 3D printer with a manual pipette strapped to it and an extra stepper motor acting as that thumb. What the robot is now is a beautiful, precision machined, beautifully industrially designed and engineered piece of equipment, but it still follows the ethos of let's tap into a super inexpensive supply chain and let's bring this technology to the masses. And so OpenTrons came way down the cost curve. The first robot we ever sold was $3,000 as opposed to the next robot you could get, which comparatively, probably there are some that were like in the $50,000 range. So we were an order of magnitude cheaper. And what the company expected upon launch was that it would be a favorite amongst the folks that like to tinker, open source enthusiasts, biohackers. What ended up actually happening was scientists from Stanford and Harvard and MIT and the University of Illinois and the Mayo Clinic were interested and were buying the first really janky version of this robot and were desperate for it because they were like, yes, we've been waiting for something like this to exist. And so that unlocked an entirely new market for lab automation. And it also enables people to share experiments such that you can have knowledge transfer now much more easily by just downloading and sending a protocol that you wrote to somebody else's robot. So you can also enable wider collaboration, and you can sort of, from the grassroots up, get more and more people into science without them having to learn the perfect pipetting technique. There are a lot of dreams still attached to Opentrons and a lot of that vision left to fulfill. The company's doing great. I'm rooting for everyone that's still working on it. As you can tell, I'm still really into it. But yeah, that's part of the story at least.
And wasn't Elizabeth Holmes trying to do the same thing with her lab automation tool? Why did she fail, and why was Opentron so successful?
One of the ways that she failed was she just didn't do the thing. But when I look at that story, I think she overcomplicated it, to be really honest with you. Like from the beginning, the vision is really compelling, right? You can run all of these tests from this very tiny amount of liquid, in this case, blood. There's a whole long rabbit hole of issues with doing blood-based diagnostics. I did a lot of that when I was at MD Anderson. It is not very fun. It is very challenging. Blood is a very complex biofluid, and we don't have to go into all of that. But I think she overcomplicated it. When you look at what Theranos was trying to do, it was extremely over-engineered, and it still didn't work. When you look at what Opentrons did, which was slap some 80/20 aluminum railing together with a bunch of off-the-shelf motor control equipment and electronics and some code and a manual pipette with a literal 3D printed piece of plastic holding it onto the gantry and a well plate sitting underneath it. That's probably the least engineered version of the thing. Opentrons, the first prototype started with, it didn't even start with something that could move in all directions. It started with something that could go on one axis and then go on this axis, but not even move on this axis, right? It was fixed moving left and right. And then you had the extra stepper motor to work the plunger. And so there is a lot to be said for not over-engineering things, not over-complicating things, starting with the absolute simplest version of the thing. Theranos might have been successful if Elizabeth Holmes was like, I have this idea. I think we can do a whole bunch of diagnostic tests from a single drop of blood. What I'm going to try to do is see if I can replicate one of those tests, and then maybe 5 of those tests. And maybe not jump straight to all 60 tests in a panel, right? That is one of the things where it's like, you try to not bite off more than you can chew, try to not over-engineer the dang thing. Figure out what is the most basic version, the most basic unit that will work. Build that version, learn from that version, build the next version, learn from that version, add complexity as you go. Don't assume you know everything up front. Maybe particularly if you're a 19-year-old dropout. No offense to the 19-year-old dropouts. There are a lot of brilliant ones. I mean,
that's awesome. All right, that was Opentrons, and I bet the team's so excited that you did a beautiful job of explaining their story and what they do, and thank you so much for that. But now you're in the world of venture capital, and you're a partner at Lower Carbon. What's it like being a venture capitalist and at a climate tech fund?
Tell us that, but can we hear how you ended up there?
Yes. I was at Opentrons still when I first started thinking about climate. And here's the thing. The 2018 IPCC report came out, and I was terrified.
Hey, y'all. So Kristin referred to the IPCC report. IPCC stands for Intergovernmental Panel on Climate Change. They are a scientific group assembled by the United Nations to monitor and assess all global science related to climate change. Every IPCC report focuses on different aspects of climate change, and this latest report, published in 2023, is the 6th synthesis report. It highlights developments in low carbon technologies, ambitious national commitments, and what we need to do to mitigate the effects of climate change. It's worth a read if you live on Earth.
One of the reasons for that is also like the most recent IPCC report came out and everyone's freaking out about that one too. And they continue to, unfortunately, get a little more gloomy and a little more doomy over time. And so in the 2018 report in particular, I remember seeing, for what was the first time for me, a description of what we needed to do. And it's, of course, we need to reduce greenhouse gas emissions. We are emitting way too much carbon into the atmosphere all the time, constantly. And then in addition to that, we could have turned off the spigot decades ago when we first started to realize that this was going to be a problem. We didn't. Now we have this massive waste cleanup problem on our hands where it is no longer enough to simply turn off the spigot. If we want to be on a livable planet, we have to undo some of that damage. We have to pull some of that carbon back out of the atmosphere. We need to do carbon removal. And I did the same thing most people do when they hear about carbon removal. And I've seen enough people go through the journey that I feel pretty confident that a lot of people go to this where they're just like, so you mean like photosynthesis, like planting trees? What are we talking about? What do you mean we need to do carbon removal? Like, we have the technology, guys. It's out there. It is the literal Earth system itself. That's what the Earth system does. In addition to biology, and my bias is thinking about photosynthesis because I'm a biologist. I was like, okay, so how much carbon removal and over what period of time? And starting to look at those numbers and wow, that seems really scary. And I'm looking out and I don't see anyone working on that problem in earnest. Like, sure, there are folks planting trees. We're still cutting just as many trees down. There's still just as many trees burning in wildfires. Planting trees is not going to cut it in an intuitive sense. So what else can we do in order to reverse that trend? And I was like, wow, this seems like a green field. It doesn't seem like there are a lot of people working on this. I am not an environmental scientist or an earth scientist, but what do I know? I know biology and biotechnology. I know how to build a company. I've done that before. Maybe there's an opportunity to go and work in carbon removal and build a Climatech carbon removal focused company. So I started thinking about that journey. And part of that was I thought about, oh, maybe I need to go back to school. I looked at programs. There weren't programs focused on this because there were general environmental programs, but nothing that quite fit the bill. And then there was an NGO called Carbon 180 that has been working relentlessly since their founding in, I believe it's 2014, on federal funding for carbon removal research. So they have been working with policymakers to help them understand why we need carbon removal at least 4 years before I had even heard of or thought about it in those terms. They were responsible for most of the research funding that had been appropriated to carbon removal from the federal government to that date. They were responsible for helping to get that funding underway. And at that point, I think it was less than $20 million for all of time. Now, fast forward today for just a second, that has ballooned with the IRA and the CHIPS Act and other things to well over $1 billion, perhaps more. I'm not sure what the exact numbers are. They really laid a lot of the foundational work to get the federal government and in particular research dollars flowing into that space. And around late 2019, they put out a call for people from tech, all walks of life, but specifically from tech. It's like, hey, if you have this background in tech, if you don't have to be an environmental scientist, you don't even necessarily have to know much about climate at all. But if you think you can build something here, apply to our entrepreneurship in residence program. We're going to arm you with the tools that you need to go and learn enough about this so that you can build a carbon removal company, because we don't have enough supply to meet what is going to be a significant demand for that in coming years if we're going to meet those IPCC targets. So I applied to that program, not expecting to get in. And I was actually sitting at the OpenTron's Christmas party with Karl Schmieder when I opened my phone and got the email saying, congratulations, you're in. And I think I started crying. I'm pretty sure I cried and freaked out. And I was like, am I actually going to leave this amazing company that I'm building, which I cared a lot about? It was OpenTrons. Am I really going to leave this company and get on this other crazy path that I really don't know that much about yet and try to go do this kind of what feels like nuts thing, right? Like really branch out and do this thing. And of course, ultimately I said yes. I did the entrepreneurship in residence with Carbon 180. I also did a commercialization fellowship with INREL. I spent a year and some change during the pandemic trying to think about, okay, how do I build a carbon removal company? What kind of company do I want to build? And sort of the short story of how I ended up at Lower Carbon from there is I flawlessly executed the failed entrepreneur to VC pipeline. I found myself coming up against some roadblocks and starting a company, realized that that time was not lost. I have learned a lot. And the thing I care the most about is jumping in and being super high leverage with everything that I know. And I started looking for, similar to how I did with OpenTrons, early startups where I could just jump in and move water. And it turns out that Lower Carbon's portfolio held a lot of the startups that I was interested in already. Also turns out that Lower Carbon was looking to hire somebody with some biotech experience onto their investing team. And the rest is kind of history. They convinced me to join. And I joined the day that Lower Carbon announced their first big fund. Pretty cool.
That's amazing. Okay, so now you have to tell us what's it like to do what you're doing.
It's the best job in the world. I hate it so much. I'll never leave. I want to quit every day. It's everything, everywhere, all at once. It's so intense. It's a job, right? How do I put this? I feel all the ways about it all the time. I love the intensity. One of the biggest privileges of being in this position, amongst all of the other privileges that come with being a VC, like not only the normal ways that people talk about, is the fact that I get to drink from an absolute fire hose of optimism and possibility around the climate crisis every single day. Every single day I show up at work and there are people raising their hands and saying, hey, I can help. I know what to do about this thing. I know what to do about reducing emissions in this sector. I have a new way of making steel. I have a new way of making cement. I have a new way of removing carbon from the atmosphere at the gigaton scale. I have a new way of shoring up our agricultural system so that it doesn't collapse under the weight of climate change. I have a new way to help people adapt to a changing climate by this new water saving technology. I have a new way to do controlled burns to fight wildfires. It is so incredible to see the number of helpers. One thing that people always say, it's like in a crisis, you look for the helpers. I think we can all agree that the climate crisis is a very real crisis. The helpers are here. The helpers are coming. And I get to spend all day, every day with the helpers. And that to me is the coolest part of this job. It's also emotionally complex. Being a VC is technically, I'm a finance bro now. I know I've said that to you before and it makes you laugh sometimes. What it comes down to is the people, right? It's really working with the people and really trying to figure out, okay, what can I do to jump in and partner with this founder or this team to help do just a little bit to ease just a little bit of the friction in this process to make sure that these early technologies and these helpers have the opportunity to actually bring their vision and their ideas to scale and really help us. Well, I don't know if I'm allowed to curse on your podcast, but it's our tagline. Unfuck the planet.
In reading about Lower Carbon, the founder, Chris Sacca, has said that he feels like he has an unfair advantage investing in climate tech. And I have a two-part question. First part, is that true and why? And number two is, in the face of all this legislation that the Biden administration has passed, does Lower Carbon still hold that unfair advantage, if that really truly exists?
Yeah, resounding yes and resounding yes. For the first part, the why, quite apart from Chris's own personal stellar reputation, creating winning investor founder partnerships in tech, maybe the most genius thing about Lower Carbon is how genuinely diverse our own team is. I don't know if a lot of people realize this, but the majority of our team identifies as women. At least half the team speaks more than one language fluently. There are not a lot of other $2 billion plus funds that can say that in climate tech or elsewhere. And I think part of why we're able to see things that others miss, because we do see things that others miss, is that we have perspectives represented on the team that most VCs are too scared and out of touch to include. In addition to high representation in demographics where VC usually fails, we have several folks from non-traditional finance backgrounds, me included. We have scientists, engineers, policy wonks, scrappy early startup operators, first-gen college grads, people who worked in the White House, people who have worked in government research, people from academia. We want excellent, mission-dedicated people from all backgrounds and all walks of life to join our team. Our team is exceptional. We see things other people don't see. And yeah, that's really the long and short of it. As for the government funding, love a good tailwind, right? When we started, and in particular, when Chris and Crystal started Lower Carbon, these tailwinds did not exist the way that they do today. We have been investing in businesses that do not require regulatory changes and do not require government funding to be successful. But all of this legislation, all of this money that is now flowing into climate solutions makes it all the more likely that these companies and these teams and these technologies are going to succeed. And we like that.
That's awesome. So you have this biology background, and now you're working at Lower Carbon, focusing on climate tech, but there are parallels between climate tech and biotech. Can you talk about that intersection a little bit?
The thing I always say is the Venn diagram of climate and biology is a circle. The whole reason for the energy revolution, wood, coal, oil, natural gas, all of that is biology. We don't talk about it like it's biology, but it's all biological material. Some of it is just slightly more aged. There's really no way to talk about climate without considering biology. Just the other day, I saw someone say something to the effect of, I can't wait until we have clothes that are made from captured and repurposed carbon. And my thought was, technically, all of the clothes are already made from captured and repurposed carbon. We don't think of petroleum that way, but that's what petroleum is. Also, we could talk about cotton and bamboo and other materials, right? But we're always, and we always have been, leveraging either current renewable or previous fossil biological activity to build everything from energy to chemicals to materials, to textiles, to fuels, to food. You cannot separate climate from biology, so you cannot even separate climate tech from biotech. They are the same thing. Now, I know that normally in an investing sense, or even in our sector, historically, when we've talked about biotech, a lot of what we've talked about has been human health focused. But we've seen a lot of companies emerging that are saying, what if we sort of reinvent the way that we think about things? And what if we reinvent the way that we make things? And so we see a lot of companies coming online to fill each of those sectors: chemicals, materials, textiles, not just the healthcare, right? One of the things I often think about is when we think about engineering biology, I love the name of this podcast, Grow Everything, because it gets back to the core thesis of biology. Shit just grows out there, right? And we can figure out how to leverage the things that the earth and that nature already do. And we don't actually have to reinvent the whole system. We can apply a little sprinkle of human ingenuity and make those systems faster, make them better, maybe transform them a little bit into things that we find useful. I think what we need to be careful of in biotech is of things that become more additional layers of abstraction than actual paradigm shift in how we are building this renewable world that we all keep imagining about, and how we're building this bioeconomy that we're imagining about. We're still going to have to grow everything, or a lot of things. We're still going to need inputs in the form of nutrients, energy, and sugar to make any of these new systems, any of these materials work. So then you have to ask yourself, okay, does the energy come from the sun directly into a plant, from the sun through solar panels, or from the sun through fossil fuels? Is it ancient sun? Does the sugar come from the plant itself, if we're growing fruit in an orchard, or from corn, or from sugar beets that we had to dedicate land to grow so we could feed that sugar into bioreactors? Sometimes I worry if we go too far down the path of abstracting and atomizing each piece of the system, we're going to run into some of the same fundamental limits that we're starting to run into with petroleum. So in my mind, it's a question of striking a balance between continuing to produce what we need today within the system and the constraints that we have, and imagining a new system then that protects, regenerates, and replenishes what we already have with well-applied ecological technologies.
Obviously, we're super biased towards biotech and growing everything, but could you, Kristin, give us some examples of where you've seen or are seeing where biotechnologies can have an outsized impact on climate?
Yes, everywhere. I'll give you some specific examples because that's only fair, because I already did the it's everything speech. Let's start with chemical. There is a lot of opportunity for us to reinvent the way that we make chemicals. And instead of making chemicals and materials from ancient biology, making those same chemicals and materials from renewable biology. Solugen is a great example of this. We are big investors in Solugen, and Solugen has the ability to make the building blocks for 90% of the chemicals industry cheaper, faster, and more sustainable than petrochemistry can. That is partly because they are borrowing, right? And here again, I use this language where I'm like, we're borrowing things from nature and we're applying some of our human talent to make it a little better. So what they're borrowing is biocatalysts. Solugen makes a chemi-enzymatic chemical synthesis platform. They use enzymes as catalysts, in addition to metal catalysts, which are often used in the petrochemical industry today. And they've taken that legacy, the hundreds of years of engineering and ingenuity that has gone into valorizing petrochemical feedstocks into materials and textiles. And they're taking some of the relatively recent developments in machine learning and enzyme engineering and taking biocatalysts and adding those into that system.
For our friends revisiting biology, an enzyme is a biomolecule that acts as a catalyst in living organisms, regulating the rate at which chemical reactions happen. In our bodies, they catalyze digestion and liver function, and in industrial applications, they are used widely, like fermenting cheese and wine, or in laundry detergent to remove stains. We will chat about enzymes often as they are responsible for making bioreactions happen.
Biology is also pretty good at making molecules. And so reimagining this technology stack where we can leverage the best of both worlds and make the building blocks, again, for 90% of the chemicals industry cheaper and better than we can make them even using existing technology, I think is really cool and is a huge testament to the power of biotechnology to have a huge impact and to really transform climate and to really transform the way that we continue to make and use and consume the goods that we all know and love and use every day.
What gets a deal funded? When you're looking at a deal, what makes it interesting for you to consider whether you're going to invest versus one that doesn't get the investment? What are you looking for?
I'm looking for a few things. And some of those things are exactly the same things that any VC would tell you that they look for at the earliest stages. I'm looking for a really strong founding team, first and foremost. It's about the people. Who is building this company? What is their vision? How will the world change when they succeed? And how are they proposing to get there? Then I look at what they're making. Are they proposing a technology that's going to enable them to make something better, faster, cheaper, tastier, equally or better performing, and with a significantly lower carbon footprint? That is part of what I look for when I'm looking at investing in one of these companies. And it's the and with a significantly lower footprint. That is the piece that is a bit different in Climatech. And we're considering more than just emissions when we look at impact. We're looking across the board. We look at water use. We try to think upstream about what the inputs are going to have to look like. We try to think downstream about what is the output of this new process going to look like. Is it better, the worse, or the same as the existing process that we're proposing to improve? Are there technologies that exist to mitigate any of the knowable externalities from that process where we might have unintended negative impacts down the line? You can only gaze so far into the future in your crystal ball when you're dealing with super early stage companies, but those are some of the fundamental things we look for. On the technology, are you breaking any of the basic laws of thermodynamics? Yes, no, that's an easy one. Then it's about what step change of improvement can you actually show me in this process? What does your techno-economic analysis pencil out to in terms of both how much economic activity, how much revenue, how much money you can generate and make, and in terms of how much better is this actually going to be in an impact sense over the incumbent system? There's a lot of other stuff.
You said that you're looking for a strong team. What makes a team strong to you?
It does depend on what they're building. There are some commonalities across the board, right? I tend to look at their background and what drives them. Their why is very important. Why are you building this? Are you building this because you think startups are cool and you want to do something shiny and you think it would be neat to raise venture capital to do that thing? That's maybe not a compelling argument. And we do see some of those, right? We see people who are playing at being founders versus being founders. Being a founder is a tall order. It takes a level of sustained dedication, commitment, and intensity to the project at hand, to the company at hand for a very long time. And it is a very hard road. It is not easy to build a startup. So we also look at, not only in addition to looking at the why, and understanding, is your why strong enough to keep you going through those late night and those scary times when you feel like you're going to run out of money, and those other times when you feel like you've made a bad hire, and those other times when it feels like nothing is working? Do you have a why that's going to sustain you through all of that? So there's a certain level of intensity and kind of relentlessness that we look for. We also look for people who are good communicators and can take feedback and can work collaboratively with others and have a good sense of who they work well with and who they would want to bring onto their team to help them with the next step. So not just the clear why and the clear long-term vision, but the clear vision for what is the actual next step to 5 steps on the path. Do you have a good articulation for how you're going to get from here to there, where the there is, in 10 years, we've succeeded, the company is wildly successful. So while we look for that vision, we also look for ability to execute. We're not necessarily looking for the most balanced people on earth. I don't think that founders are always the most balanced people because it requires so much intensity and so many long hours. What we are looking for is people who are going to work really hard on the problem, know themselves really well. And then depending on what they're working on, their technical background can be very important at that early founding stage. We see a lot more highly technical founders in climate tech than we see in some other sectors, mainly because it requires a certain amount of technical expertise to build a lot of these companies.
Can you give us some examples of deals Lower Carbon's invested in and maybe why those are important companies for the fund to be a part of?
Yes, I can. One of the companies I love working with the most is Urban Machine. They're based out of Oakland, California, and they are building recycling robots. The big picture there is that 23% of the entire US national waste stream is construction and demolition debris. After concrete, wood is the second largest category of C&D waste. But unlike concrete and steel, which have relatively high recycling rates, most construction and demolition derived wood waste goes straight into landfill. Over 80% of it goes straight to landfill. In the US, that nets out to right around 40 million tons of potentially salvageable wood waste sent from demolition sites into landfills every single year. Salvageable does not mean savings, because salvaged wood is actually significantly more expensive thanks to the labor involved in making materials suitable for reuse. Meanwhile, the US also harvests the largest volume of trees in the world, cutting down millions of them annually on shorter and shorter harvest cycles to sustain the demand for lumber as our rates of construction continue to increase. If you think about all of that organic material going into landfill, and you think about potential ties with landfill methane emissions and potential ties with forestry and timber, and potential ties with just massive waste streams and logistics and all of the diesel and gas that you have to burn, getting all of that material to landfill, you're looking at a pretty significant emissions footprint across the board. That's the bad news. The good news is, as with a lot of our companies, the scale of the opportunity is proportional to the scale of the problem. And that is where Urban Machine comes in. So they're on a relentless mission to convert all of that construction and demolition wood waste into billions of dollars of a year worth of high volume, locally sourced premium lumber products by building mobile machines that leverage the latest robotics, computer vision, and machine learning to salvage lumber waste so it can be used to build again at a price competitive to virgin lumber. So what they're proposing is to add some human ingenuity and automation to this problem to turn the unit economics on their head and make salvaged wood as inexpensive or cheaper than virgin lumber and create an entirely new circular supply chain of wood in the construction economy. That is really cool. We get excited about that both from the impact perspective and from they could create an entirely new market perspective, right? There's an incredible wealth of information they can collect from this. You can think about the matching the supply side with the demand side. They're going to be able to build up, using this computer vision machine learning, a better picture of exactly what kind of material and quality of material you can expect to come out of a building that was constructed in 1970 and how much of that material, and match that with somebody that then wants to take that kind of material and use it in a new construction project than anyone else in the world. We can see them building up also like a really significant insight and data set into what is actually out there just waiting to be salvaged and reused. Right now, we don't really have a good sense of that. So there's just layers and layers of this. And so one of the additional things we love about this is there are potentially second and third order effects of building just this recycling piece, put a quarter in the just jar, that unlock bigger and bigger potential, not only for Urban Machine as a company, but also for efficiencies across the building industry as a whole. And so this is the kind of company that we and I get really excited about for all of those reasons, plus some. The team is really awesome as well.
That's so cool.
I know you have so many companies under the lower carbon umbrella, and we'd love to talk about them more, but you guys also evaluate the impact of these companies. Do you have any impact numbers across your portfolio that you can share with us?
The answer is yes and no. Near term, these are all still very early stage companies. We have a lot of impact projections from those companies that we look at. Near term, it is hard to say what the cumulative impact of those technologies is going to be. A lot of them are still pretty early. Latest stage in our portfolio, I think, is Series D, which along the life cycle of a company is still very early. And in a lot of climate companies, we're still barely scratching the surface. So when I say yes and no, the no is, do we have specific numbers from companies that we can point to and say, here is an active example of this company having reduced these emissions by 100 million tons a year? Not yet. I think we're going to get there. And so one of the interesting things about our portfolio, and this is a little bit of inside baseball for you because you're my friends, in climate, we think about CO2 in parts per million, right? We've all heard about parts per million, how the amount of carbon dioxide in the atmosphere is going up so many parts per million per year. Lower Carbon actually manages a few early stage funds, each with a different name. And the name of each fund is actually the parts per million of CO2 in the atmosphere when that fund was launched. So when we raised that fund, what was the parts per million of CO2 in the atmosphere? Our first fund was 411.2. So that is actually the first fund that Chris and Crystal were investing out of. Then we had 419.1. That's actually the fund that we announced when I joined in 2021. So those are the parts per million of CO2 in the atmosphere at the time when we raised those funds. Long term, I like to think of this as, well, I'm going to know if this fund has achieved its impact number, if the parts per million of CO2 in the atmosphere is ever below the number that is the name of that fund. That is a really big goal. But again, like going up full circle back to how I started in this journey, thinking about carbon removal and turning back the clock, I actually want to see that number go below 419 ppm. And I'm going to feel really good about it when it does. So long term, that's one of the fun ways that I like to think about it.
That's great. You said that you're drinking from a fire hose of optimism, but do you really think we can save the world? Do you think it's something that we can leverage these companies and mitigate climate effects to not reach that 1.5 degrees that everyone's pointing out? And what happens if we don't?
I think yes. And the reason I think yes, this is not blind optimism. The only thing bigger than the climate crisis is the opportunity to solve it. Okay. And what are we good at? We are good at running against a problem and solving it. Not only am I sure that we can save the world, as we're saying, I think there's a tremendous opportunity to do a lot of good in the process of rebuilding our economy on efficient, ecologically sound foundations. We have learned some lessons, I think, from the ways that we have built things previously. A lot of the ways that we've built the world were built with the best intentions, with this kind of relentless human ingenuity and problem solving in mind. I think we can do it again, and I think we can do it better. And I think we can capitalize on that opportunity, both in a literal dollar sense and in a human capital sense and in all the senses, and really build better for the future. I don't want to pretend like there aren't going to be challenging times ahead for a lot of people. We're already seeing the effects of climate change today, particularly in a lot of frontline communities, particularly in a lot of communities that are already economically disadvantaged. One of the things that we have the opportunity to do as we rebuild is to pay attention to those places, to build in those places, to help those places adapt, and then to make it so that adaptation does not have to be the story anymore, to make it so that we're building into abundance and we're building into plenty for everyone. And that's aspirational, but the more time that I spend in this sector, looking at all of the people that are coming to help, the more it feels also realistic, right? The more it feels like actually we can do this.
Awesome. Good. That's reassuring. Thank you for reassuring us.
Why don't we just end by talking about what do you see as the future of climate tech in the next 3, 5, 10 years?
I think over the next 3, 5, and 10 years, climate tech is going to continue to become more and more predominant in conversations, both in venture capital and the early stage funding sector, but also in more mature sectors. I think we're going to see it take center stage more and more until it actually becomes the story. If you are not thinking about climate as a part of your business strategy, you don't have a business strategy. I think ultimately all of the jobs are going to be climate jobs, right? The future that we are headed towards is one that takes into account our impacts on the earth, on earth systems, on other species, and calculates those into how we're actually building these industries, how we're building these supply chains, and how we're building the world. And so tactically, I think we'll see a lot more public funding come into backing early stage and maturing climate solutions. I think we'll see a lot more government programs focused on procurement for maturing climate technologies, procurement for carbon removal, procurement for energy storage technology. So I think we're going to see a lot more of that support. I'm hopeful that we're going to see a lot more international cross-border support and a lot more early stage companies and early technologies and early research coming out all the time to help us wrap our heads around and understand what we can build and what we can build better.
Awesome.
Woohoo!
All right. Well, Kristin, thanks for taking the time today. This was such a great conversation. Let us know when you're around. We'll hang out. There's been a lot of good stuff going on.
Awesome.
See you guys. Yeah,
Yeah.
thank you.
Good to see you too. We miss you.
I miss you. We need to have some biotech hangs.
We will.
Awesome.
Thank
All
y'all.
right,
Thank you. Bye. All right. I always say, what a great interview. It just goes without saying that that was a fantastic interview. Kristin is fantastic.
She's very clear, smart. I loved the way she made things that were so complex, like biology, climate tech, investing, very approachable for anyone to listen to her. Like, she's a pleasure to speak with. That's why I think she should be a biotech celebrity. You got to figure that out.
Yeah. I'm just impressed by the number of companies that she meets. We meet a lot of companies. We're always talking to companies. We're meeting new companies. Kristin is next level.
Yeah, she's absolutely next level. She said that she's drinking from a fire hose of optimism. And I hear her. We both meet lots of founders and their optimism and vision is infectious. But like she was mentioning, it can be draining. Because when I hear or meet founders, my mind just starts thinking of all the ways they'll succeed, but also fail. And then I feel compelled to join them and scenario plan. Founders are bombarded with
tons of unsolicited feedback. And in many cases, they're just looking for people to come in and take the lead on one specific tactic, which is what we do at Messaging Lab when it comes to marketing and communications. Little plug there. But they need someone to come in and help take the wheel on one specific tactic so they can continue doing the big things like sales, fundraising, or getting the product ready. So like I hear her, showed me her database on her computer, had thousands and thousands of companies, is very well organized. I was like, wow, the amount of insight they have on the market at lower carbon is incredible.
We'll never discount the competitive advantage of having a lot of data, especially if you're going to be investing in early stage companies. But yeah, so Kristin is amazing. And was there any of the companies that she mentioned that really stood out to you?
She mentioned a company that makes concrete in a renewable, clean way. And I thought that was a great setup for us because we actually met Lauren Burnett, who is CEO of Prometheus Materials. And I'm excited to share that with our audience. That should be released in a couple of weeks. Concrete sounds like a boring topic, but the product that they're making, because it's not concrete, it's a new material. And it's so fascinating. I was just blown away. And I could not believe that I became so interested in concrete just by hearing what Prometheus Materials is doing specifically. So I'm excited for everyone to hear about that.
So I mentioned that interview to my wife, Kristin, and she said, isn't concrete one of the most polluting industries, if you want to call it that, on the planet? And I was like, yes, it is. It's responsible for 8% of all global greenhouse gases. So it is incredibly polluting, and yet it's everywhere. And given the amount of construction that we plan to do over the next few decades, it has a potential to continue to contribute to greenhouse gases. So I think it's really important for solutions like Prometheus to come on board. One final thing as we close out, Erum and I will be at Ferment next week. Ferment is Ginkgo Bioworks annual meeting. It takes place in Boston. It's a small group of about 300 people. Ginkgo will be presenting several companies that are in their portfolio. I'm sure we'll hear what kind of progress Ginkgo is making. We're expecting to see a lot of friends, and we'll be in Boston next week.
Yeah, we'll certainly give a rundown of who we meet, what we see, what we hear about at Ferment, so everyone can get a bit of insight as to what was going on behind the scenes.
Absolutely. So with that, thank you again for listening to us. We are now over 20 episodes, which is amazing. We get feedback from people every week. The feedback continues to be very positive. We should pat ourselves on the back because we're doing a good job. So thank you to all of you for listening to us. And please let people know that you're learning something on Grow Everything, and share your questions or thoughts with us. Thank you so much.
Yes. Goodbye.